Everyone, I'm Wendy. Today I'm going to explain about the residual analysis. What is residual analysis? It is important to know about that. Chapter 7, analysis of variance, and the Chapter 8, regression analysis, they are models, right, for statistical analysis method. And the model includes assumption. What is assumption? Epsilon, error terms follow normal distribution with mean zero and some variance sigma square, right? We have to check that assumption by what? Residual, because residuals are the value of error. Let's see what we have to do in residual analysis. Okay, it can be thought of as a process to check whether the assumptions regarding the errors in the regression analysis model are correct. Okay? It was already mentioned that residual analysis is necessary in analysis of variance as well. As has been reiterated, the assumption about errors are checked using the residual, which are the realized values of the errors. Since the mean of residual is always zero, the checks will involve two main questions. Can we say that the residuals follow normal distribution? Second, can we say that variances are equal? Equal means variances are constant, okay? So we have to check two of them. Epsilon I follows normal distribution with mean zero variance sigma square. Okay, that is assumption. The mean of error is zero, is no problem. Okay, so normality, normal distribution, and constant variance to checkpoint. Normality of residuals. The simple way to access this is to create a normal probability plot in PP, something like that, and visually inspect it. In other words, this graph shows whether the empirical percentiles obtained from the sample align with the theoretical percentiles of normal distribution along a reference line, 45-degree line. This is a 45-degree line, okay? So theoretical percentile and empirical percentile from the sample. So this one is a theoretical one, and empirical percentile means that percentile from the sample, okay? That should be coincide. That is perfect normal distribution. Otherwise, for example, let's see. For example, when we create a normal probability plot for arbitrary residual values like this, okay, we can determine whether the data follows normal distribution based on how closely the residual values align with the 45-degree line. Naturally, this assessment may involve some subjectivity. So we just look at this kind of a normal probability plot and the distance from the line, okay, the values, residual values, uh, cross the 45-degree line or not. Just that is some subjectivity, okay? So normal probability plot can be obtained by computer, so you don't worry about that. But that is subjective. So objective method is Shapiro-Wilk test. Shapiro-Wilk test is a more objective method than normal probability plot. Okay, this test has null hypothesis is H0. The data follows normal distribution. So even any data, if you want to check that data follow normal distribution, you may use Shapiro-Wilk test. Okay. Okay. Thus, we decide that the data follows a normal distribution when the p-value h naught is this, when p-value, sometimes it can be noted like this, probability less than w. The p-value associated with the tested statistic w is large, so that we cannot reject h naught. Then the data, it means that data follows normal distribution, right? So p-value, most case, when you analyze data, most case, the p-value, small p-value, the better result. I mean, the stronger you reject h naught, the smaller. But here, the p-value is large, then what? The data follows normal distribution. Okay, the process of calculating the test statistic is omitted. Okay, actually, it is very complicated. So you don't have to worry about what test statistic W is. Okay, let's see simple thing here. Shapiro-Wilk test. H0, the data follows normal distribution. H1, of course, what? Not H0. Data, it is a simple data here. Okay, 2.3, 2.1, something like that. 10 data point. Shapiro result. This is from Python. Statistic, value of a statistic is 0.9437. What? W is 0.9437. And the p-value is 5955, almost 0.6. So H naught cannot be rejected. So these 10 data, we can say, follows normal distribution. Okay? All right, that's it today. I'm going to explain a little more about residual analysis next time. Okay, thank you. Bye.